to this video on least square regression and residual plots. By the end of today's video, you should be able to determine the equation of a least square regression line using technology, and you should be able to construct and interpret a residual plot to assess whether a regression model is appropriate. Alright, so today's story context is going to be how many iPhones will be sold. So they're giving us our data, and I want you to pause the video and sketch a scatter plot over here. Don't forget to name your axes, and when you're done, start the video back. Alright, so here is our scatter plot. Now, let's take a look at this. We want to describe the form. Remember, the form is the shape. When I look at this, I feel there's a very definite curve going on right along here. So I'm going to say the distribution looks nonlinear because we don't need to be specific. It's just linear or nonlinear at this point. Alright, so it's nonlinear. But remember what I was saying before, that when we talk correlation coefficient and all that kind of stuff, we're talking about lines. So we're not going to calculate any correlation coefficient on this because it wouldn't be appropriate. But there's a way to investigate whether this is actually linear or not, and so that's what we're going to look into now. So I want you to take your data, take your calculator, and let's calculate the least square regression line. So you'd go into Stat, Edit, and you're going to put the years into the list 1 and the units sold into list 2. Now, one thing about this is sometimes if they don't say anything, you're going to put the years in, but sometimes they'll say the year since a particular date, so you wouldn't put the entire year in, you would only put in the year since that date. So it just depends on each problem. Once everything's in, Stat, Calc, choose number 8. My data is in list 1 and list 2. Okay, now that gives me a correlation coefficient. You can always calculate one. It's not appropriate for this model, so none of the R and R squared are not important. We have our A and B. Let's plug them in. So remember, it would be y hat equals -3, 2, 2, 2.633 plus 1.605 x. So I want us to put this in context. What does the y hat represent? It represents the units sold. So we're going to put a hat over that. And then we're going to finish out our equation. 222.633 plus 1.605. And the x value will be the year. So there it all is in context. Okay, so we're going to use the least square regression line to calculate the residual for 2007. So remember, our residual is the actual minus the predicted. So I want you to pause the video and calculate the residual and come back and see how you did. Leave some room because we're going to interpret that residual. Alright, so let's see what you've got. I have my predicted units sold. I have my equation of my least square regression line. I plugged in 2007 and got -1.4 million units. So that's what was predicted. So remember, residual is actual minus predicted. So I have my actual amount from the table above and my predicted, and I got 1.9 million. So I have a residual, which means kind of a leftover number of 1.9 million. So to interpret that, we're going to say the actual number of units sold was 1.9 million lower than predicted for 2007. 1.9 million lower than predicted for 2007. All right. So a residual is just the difference between what was predicted and what actually happened. So what we want to do is we're going to make a residual plot. We're going to graph the residuals. So when you come over here to graph this, you're going to use the original x value and the residual value to graph. Okay, so I'm going to help you get through this. You're going to have, here's your x value, your residual will be your y value. We're going to graph it over here. So we had our original units sold. Actually happened was 0.5. Our predicted value was negative 1.4. And that's where we got that residual of 1.9. So to graph it, we're going to go to 2007 for our x value and approximate where 1.9 is for the y value. Okay? And so I want you to work through all of these and graph them on your residual plot and then restart the video. Alright, so I just brought down, we have our actual units sold. I plugged in each of the numbers and got the predicted numbers of sold and subtracted them, and here's my residuals. When I graphed them, here's what I ended up with. You should have something pretty similar. Now the question 7, for which points was the actual greater, was the actual greater? So the actual greater occurred right here. What really happened was greater than predicted. So this shows actual greater. And so does this one over here. So I'm going to kind of do them in groups because they were separated. Okay. And then this group down here, you got a negative residual because your actual was less than what was predicted. So this is the actual was less than predicted. Okay. So do you think the regression line was a good fit for the data? So what I'm going to tell you is I'm going to tell you the answer and we're going to go back and talk about all this stuff. Okay, so I'm going to say no. It was not a good fit of the data. Okay, and here's why. The residual plot looks curved. It's got a positive residual, negative residual, positive residual pattern. And we'll talk about this in just a second. So the distribution is not linear. Okay. So when we make a residual plot, a good residual plot should have a random scattered pattern. So, good residual plot should have a random scatter. When we look at our points, these are positive, meaning they're above the line, these are negative, and these are positive. That's that positive, negative, positive. And when you have that going on, your results aren't scattered, they're actually curved. Okay? We could have had the opposite. If you had negative, positive, negative, that would have been a curve going the other way. So whenever you see a pattern in your residual plot, that is not a good thing. Patterns are problems. That means the distribution was not linear, which we suspected up here because we were seeing a curve going on up here. Okay, So you do not want to have any patterns show up in your residual plot. So let's kind of summarize this down. We had a whole lot going on in this activity. So I have two things that I want to tell you. I think we can get by along that much room. So the first thing I want to tell you about is the least square regression line. So your least square regression line, and it's often abbreviated LSRL, so if you see that, that means for the least square regression line, it's the line that best finds the exact center of the data, and this line will have the smallest sum of residuals squared. That's why it's called the least square. So you're just minimizing the error from the line with this line, and that's always what your calculator gives you, is that number. Okay. Another thing about that line is it's always going to pass through the point x bar, y bar. Remember, x bar is the average. So this is the average of the x's, and this is the average of the y. So it will always pass through that point. The other thing I want to summarize up for you is your residual plot. Okay, so when you draw your residual plot, you've got your x-axis, or your y-axis, not your x, your y-axis, and this is your x-axis. Remember, your explanatory is your x-axis. Over here on the y, this is your residual. Okay, so the residuals are going to center around 0. You'll have your x scale going out this way. Residuals, that'd be like 1, 2, 3, -1, -2, -3. And what you're looking for is you're looking for this nice random looking scatter. So you can't really tell a pattern. It's kind of all scattered out. This is good. This is what you want. That means the data it came from was linear. But if you had a residual plot that is curved, that's bad. You don't want this. Bad. Don't do it. Okay? So you want a nice pretty scatter on your residual plot, and that's how you know the data was linear. So we want our residuals our residual plot to show a random scatter with no leftover pattern. Alright, so what I would like you to do is I would like you to pause the video, try this on the Check Your Understanding all on your own, and then I'll show you the answers. Okay, let's see how you did. For my least square regression lines, I inputted the body weight into list 1, your backpack weight into list 2, and I got predicted backpack weight is 16.2649 plus 0.098 times the body weight. Okay, so make sure you're putting it in context. It will help as we move along. For my residual plot, I graphed all of the residuals, and then I noticed if I looked at them as I went along, I ended up with 3 groups. So I've got a negative, positive, negative pattern. It's not a nice scatter. It shows a clear curve going on. So for that reason, because the residual plot pattern appears to be curved, and then I said it was a negative, positive, negative pattern, the linear model is not appropriate. Hopefully this was helpful. Be sure to let me know if you have any questions. See you in class.
Yeah.